Now, in this IBDP chemistry portion, we are seeing alternative fuels. In our earlier video, we learned about, in earlier lesson, we learned about the hydrogen fuel cell. These all these activities we are doing, why we are doing these activities? Because we have to make sure that we are saving our non-renewable energy sources, such as crude oil, such as coal. This is fixed, right? Or so that our future generation can use it. So these are all the efforts where we can shift to shift from non-renewable the energies, because we have to save it for a future generation in the sustainability aspect. Secondly, all these non-renewable sources of energy, such as crude oil, petrol, diesel, aviation fuel, or coal, this releases huge amount of carbon dioxide. This carbon dioxide is a greenhouse gas. So how can we save our mother earth? Well, because temperature rises due to the greenhouse effect. So that's a very important point we have to master. Now, moving to this part, we have to know that whenever we are seeing that that the hydrogen fuel cell, that was an option, a wonderful option where we are getting water as a product, but it also has got some tags associated with it. That's sources of hydrogen. Still now we are sourcing the hydrogen from electricity of water, that needs huge amount of electricity, and electricity is generated from coal mainly. And that's the reason we can also use steam reforming of the hydrocarbon, where we add steam, we get
Yes.
carbon monoxide plus hydrogen. This carbon monoxide will be further reacting with the lots of H2O gas which is there in the chamber to give you carbon dioxide plus hydrogen. Now, moving to the next part, we know that if you see that when you talk about the second kind of fuel cell which is there, the second kind of fuel cell is direct methanol fuel cell. Now, what happens in this direct methanol fuel cell? In the direct methanol fuel cell, we have to know that we are trying to take what? A source of hydrogen ions, right? You have to take. From where do we get? From methanol rather than hydrogen gas. Now
Yes.
this methanol can be easily produced, right, by fermentation, right? We discussed that we can produce alcohol by fermentation of plants. So we can very well use methanol. We can get methanol from renewable, so from the renewable sources of energy, such as plants mainly, through fermentation process. And methanol is cleaner. Why methanol is cleaner? Because hydrogen, what we get, again I'm telling you, hydrogen we are getting from mainly electricity of water, that uses coal to generate the electricity. So hydrogen still will be sourced for the coal. So methanol is much cleaner, and it will be having a less impact on the greenhouse gases which is coming out. Now now you have to remember that one of the most important thing, we have to understand the hydrogen, the energy density, that is the energy per unit volume, right, is very different, right? Isn't it very different? If seeing the hydrogen gas, it has got a very huge amount of volume it occupies. Why? Because uh, this hydrogen gas, 2 grams is 1 mole, and we know from the
Mm-hmm.
Avogadro's law that 1 mole will be occupying 22.4 decimeter cube, isn't it? So to carry 2 grams of
Yes.
hydrogen, how much amount of the volume you need of the cylinder? 22.4 decimeter cube. Isn't it? Do you get my point? It has got a very less amount of energy per unit volume, because this is a major challenge. In order to transport 2 grams of hydrogen, that is 1 mole. 1 mole of the gas occupies how much? At SCP 22.4. So that's the reason. See, if you see oxygen, see, 32 grams, right? 32 grams will be carried in what? 22.4 liters, right? Or decimeter cube. On the other hand, if you take hydrogen, what's the MR of it? 2 grams. So this 2 grams will be occupying how much volume? 20.4 liters. So see the difference. So a very small amount of hydrogen gas, 2 grams, you have to occupy a huge amount of volume. So that's the reason you're seeing that if you consider the energy per unit volume, methanol has got a far more energy per energy density. Energy density is what? Energy density is energy per unit volume than a hydrogen gas. Now we have to remember this process. In this direct methanol fuel cell, what do we get exactly? In the direct methanol fuel cell, we are having the anode half reaction and the cathode half reaction. In the anode half reaction, what happens? In the anode half reaction, we are taking in the methanol. Where are we getting methanol from? From the plant's fermentation. See, so it's a very good source. Plant's fermentation we are taking, and we are getting what? In the anode, what we are taking? With the anode, we are pumping it. This source is the anode we are getting. The cathode we are taking. Anode and the cathode. In the anode, what we are trying to take it? Anode we are taking in the the methanol we are taking. Now, when we take methanol in the anode, right, what happens next? It will be reacting with water to give you carbon dioxide plus 6H plus 6C. In between the two electrodes, we are taking what? We are taking a proton exchange membrane. Same setup, proton exchange membrane. What does the proton exchange membrane do? Proton exchange membrane will allow H plus ions to pass from the anode to the cathode through this exchange membrane. And see, 6 electron is generated. Can you see this? You have to somehow we have to generate the electrons to pass through electric wire, right? What is the electricity? Electricity is what? Electricity is the passage of electrons, right, through a wire is called as electricity. So somehow what we do, somehow we have to make sure that the electrons is being generated. See how many? 6 electrons. That's a huge amount of electrons, right? So the electrons will be coming from the anode and coming reaching the cathode over here. So 6 electrons will be coming from the anode and reaching the cathode over here. And alternatively, what we're getting? H plus ions. These H plus ions will be moving through the proton exchange membrane, right, over here and reaching the cathode. Now, in the cathode, what we are pumping? In the cathode, we are pumping oxygen gas, right? We are pumping oxygen gas over here. And what happens? Oxygen will be reacting with the H plus coming from where? From the proton exchange membrane. And the 6 electron does its work, generate electricity. We can put
Yes.
an electric motor. And see what is the reaction? 6 electrons is getting added with oxygen and suffering reduction. What happens in cathode? Reduction happens. 6H plus 6 electron gives you 3H2, right? So ultimately, if you add up this reaction, what we are getting? This gets cancelled off. And what we are getting? We are getting methanol plus oxygen gives you carbon dioxide plus H2. We might be wondering that this is also generating carbon dioxide, right? We might be wondering this is also generating carbon dioxide. But the carbon dioxide is generated. We have the option to produce from methanol. Methanol is produced from fermentation still now, right? We can use fermentation. And fermentation, what we do? We have to use lot of plants to grow. We have to grow a lot of plants because the production of the methanol is 15% yield. So you have to forced to plant lot of plants, and this plant will be absorbing the carbon dioxide which is getting released. So this is very important. Now, if you see that what are the anode you are taking? In the anode, we require a catalyst which contains ruthenium and the palladium. These are expensive, right? These are expensive metals, right? What are the advantages and disadvantages we are seeing, right? Isn't it? That okay. That the main disadvantage is that the anode is costly. You have to use very costly metals. Second disadvantage is what? The toxicity of methanol. Just remember one thing: methanol is the brother of ethanol, isn't it? If you take methanol, this is a younger brother of ethanol. Just remember one thing, that the alcohol which is fit for human drinking is ethanol. But you'll be stunned to hear that the younger brother methanol is very toxic. Very toxic. Even a slight amount of methanol can cause death on drinking. So this is very important. The disadvantage is the toxicity of the methanol we are using, right? So this is very important, that if you see that what are the distinct particular disadvantages of this? The distinct disadvantage is that the methanol is very, very toxic. Second, the anode is costly, right? Precious metal you have used. What are the distinct advantages we have seen? We have just discussed. See, if you take methanol, see CH3OH. So we know that 1 mole of any gas at STP occupies how much volume? Please tell me. 22.4 decimeter cube, right? This is the volume which you take, right?
Yeah.
So if you take methanol, see 12 plus 3 plus 16 plus 1. So how much you're getting? It's 15 plus 6, 70. So how much you're getting? Please tell me what's the MR of this? So this is how much getting? See, this is for 32. See, so 32 grams is 1 mole. That occupies 22.5 decimeter cube. But hydrogen, if you see, hydrogen is 2 grams, right? Is 1 mole. That occupies a larger volume, right? Huge, 22.4 decimeter cube. So another distinct disadvantages of this is what? The high energy density. So this is very important, that you can get this chart in your paper number 1B, that if you take the energy density, right? So you'll be seeing that the direct methanol fuel cell has got a huge energy density compared to the lithium ion battery also. So this was all about what? This was all about the portion of what? The direct methanol fuel cell. And we get a comparison also. This comparison is very important. See, the energy density of hydrogen is what? See, 1.9. Because why? Because 2 grams is the MR, that is 1 mole, that is 22.4 decimeter cube, right? So this is very important. Yes, hydrogen, when you burn, it releases lot of energy. Specific energy is this, right? So energy density is very low. So this comparison will be very important. This part is very important. See, you can get an idea about it. So this was all about the direct methanol fuel cell we are getting over here, right? Thank you so much. Thank you. Thank you.